Hello everyone, for this tutorial video, I'd like to explain how to find minimum and maximum values of a function, as well as explain the two separate types. The first type of minimum or maximum is called an absolute minimum or maximum, and the second type is called a relative. Collectively, the minimum and maximum of a function are called the extrema, which is Latin for the extreme points, or more literally, the utmost points. Mathematically/numerically speaking, the function will have an absolute maximum at a point if that point has the highest value out of the entire domain. Likewise, the function will have an absolute minimum if it has the smallest point within the entire domain. As we may be able to guess from the title, relative extrema are different because they are the maximum and minimum of relative points, so they are only extreme compared to points nearby and not the entire graph. We say, more mathematically, if we take points relative to a certain point, we take points local to the point we are evaluating at. One distinction to notice between relative and absolute extrema are that relative extrema must be extreme compared to x's from both sides. They can never occur at the endpoints of the interval, which is not true for absolute extrema. For example, if we were asked to define the absolute and relative extrema of this graph, we would see x equals 0 as the absolute minimum and a relative minimum. X equals 2 is the absolute maximum, but we have no relative maximums because we do not have anything approaching from either end. It is only approaching specifically from the left. We can state as well that if the function is continuous on every point in the interval from a to b, then there are two numbers, a lesser than or equal to c and d lesser than or equal to b, so that function of c is an absolute maximum and function of d is an absolute minimum. This theorem, by its definition, does not give us exactly where the extrema will occur, and neither does it guarantee how many times the extrema will occur. It only says they will occur at least once within the interval. If the function is not continuous, as this graph shows, the theorem will not work. But we should point out too that if a function is not continuous at a point in the interval, this does not automatically guarantee that the extreme value theorem will not work, as this graph demonstrates. It clearly does have an absolute maximum and absolute minimum, even though it has a point where it is not continuous. Next, we can deduce Fermat's theorem, which is used for critical points, by stating that if the function has relative extrema at x equals a specific value of c, and we know the derivative at that point exists, then x equals c is a critical point of the function. And because the derivative exists, the only type of critical point it can logically be is the type where the derivative is 0. This makes sense from consulting different graphs and seeing how, at the relative maximums and minimums, the derivative equals 0 because the function is flat. If this graphical proof is not satisfactory enough, we can state that at a maximum point, the function of point c must be greater than or equal to the function of c plus a small change in x. Rearranging this formula, we have function of c plus change in x minus function at point c is less than or equal to 0. We divide everything by change in x. Take the right-handed limit of both sides, as well as the left-handed limit so that the normal limit exists. We see that we are stating that the derivative must be lesser than or equal to 0 by the literal definition of the derivative. Instead of doing all of our steps from scratch, we can simply flip the lesser than sign to state that at a minimum point the derivative must be greater than or equal to 0. We see because the derivative is lesser than or equal to and greater than or equal to 0 at the same exact time, the only way that both of these conditions will be satisfied is if the derivative is exactly equal to 0. In conclusion, the derivative at a relative minimum or maximum is exactly equal to 0. And we know, by the definition of the critical point, that C must be a critical point. We must be careful about this kind of theorem, however, because even though it does say all relative extrema are critical points, it does not guarantee that all critical points are relative extrema. As we can see in some graphs, such as the one of x cubed, we have critical points where the slope is 0, but even though they are critical points, they are not extrema. So in conclusion, if we want to find relative extrema, we would simply find the critical points, and we know how to compute the critical points from the last section, but also pay attention to the fact that not all critical points automatically guarantee an extrema. In the next tutorial video, I'd like to discuss how to find the absolute minimum and maximum specifically, and ignore the relative minimum and maximum for now, as the absolute values are more important for problems involving optimization, as we will see later. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.